Hello everyone, my name is Jason, and in this video I'm going to show you how to calculate a set of z-scores, that's this column right here, from a set of x-scores. And in this case we're dealing with a sample, so you'll notice all the notation we have is unique to dealing with samples as opposed to dealing with populations. Now here's the two formulas that we're going to need. We have a big M, and that represents our sample mean. And we have big M being equal to the sum of x divided by little n. And little n is the number of scores in our sample. In other words, it's our sample size. So we have a formula for the mean. We also have a formula for the z-score, and that's equal to the x value minus the mean divided by the standard deviation. Now, if you want to learn how to calculate the standard deviation for a sample, you can check out my other video, but in this case we're given the sample standard deviation, and it's equal to 2.2. Now, for the purposes of calculating the z-scores, I'm going to just approximate 2.2 to be equal to 2. So I'm going to round to the nearest whole number just to make our calculations easier. Again, we're doing this by hand, we're not using a calculator, so it's nice to have big whole numbers. So the first step we're going to do is to solve for little n. We just want to count how many scores we have in our sample. And in this case, it's easy to count that we have 5 scores in our sample. The next step is to calculate the sum of x. So we're just going to add up each of these values. 1 plus 5 plus 7 plus 3 plus 4 is going to give us 20. And then finally we want to calculate our sample mean, and we know from our formula over in the top right here, sum of x divided by n is going to be 20 divided by 5, which is going to give us a mean value of 4. Now we're ready to fill in this column here, x minus the mean, x minus m. So we're going to do 1 minus 4 is going to be equal to negative 3. 5 minus 4 is positive 1. 7 minus 4 is positive 3. 3 minus 4 is negative 1. And 4 minus 4 is 0. Now we can calculate our z-score here. We've calculated the numerator for the z-score formula, and we have the denominator. We've been given the standard deviation to be equal to 2. So all we have to do is then solve. So negative 3, which is our numerator, divided by 2, which is our denominator, equals negative 1.5. Plus 1 divided by 2 equals plus 0.5. Plus 3 divided by 2 equals plus 1.5. Minus 1 divided by 2 equals minus 0.5. And then 0 divided by 2, well, that's just 0. So if you've seen my other video where we're dealing with the population, you'll notice we get the same values. We only got the same values because what I had approximated our standard deviation to be was actually equal to the population standard deviation. So if we had used 2.2, we would have gotten different values here. Okay, and so that's why you're seeing that similarity. But the main thing from this video is that you notice the difference being used in notation when we're talking about a sample versus a population. So here's our z-score values, and here's our original x-score values. So now you can communicate to someone a z-score value, and if you provide them with the standard deviation, they can figure out, for example, the actual x-score. As long as you provide them with the mean. So thank you for watching this video. If you have any questions, please feel free to message me. Till then, cheers.